All right, folks. Evening. Sorry for the delay. Okay, so basically what we're doing here is we're going to go through the question 2 on the papers, right? So I pulled from 2015 all the way to Jan 2025, including the May papers in between, right? But of course, as we know, sometimes trying to do multi-topic revision doesn't really go as well as topic by topic. So as like on the page I have there, I have all the indices together. But the funny part is after that, I decided I wouldn't do that format again. So then I put it page by page. So on some of those pages, only have like one question, but I rather have more space than they don't have enough space to write, right? So the sequence in which you see it listed there is not necessarily the sequence in which I will do it. And I also didn't finish pulling all that I want to pull because I didn't. You'll notice I have no factorization and quadratics yet, but it's coming, right? I estimate this will take us this week, next week, and the Wednesday after that. That's about 4 days. And after that, we have 2 days in next week. So anything we didn't finish here, we'll put to them, but I want to definitely go over circle geometry, like what they're doing there, as well as well, as many things as we can put. Statistics is something we definitely want to take a look at as well, because they've introduced some new aspects to probability as well. Yeah, I also want to think in all those shapes and measurements, area, surface area, volume, all that kind of thing, because that'll be a troublesome one, right? But we'll take a look and see. The patterns question. Okay, so Juliana coming on just now. Okay, so first thing I pulled up here was the indices stuff, right? So we only have about 5 questions in all those years, which I found kind of strange, but that's what it is, right? So here's my question. You all just want to dive right in and do it, or you all want me to just kind of revise the laws of indices first before you start? Yeah? A little quick revision? Okay. So let's do that first. Right. So laws of indices. Okay. Is that blue? All right. So law 1. So let's say we have x to the power a, and then multiply that by x to the power b. Now, first of all, let's kind of pull that apart so you know what we're talking about, right? So let's say x to the power a is equal to not y, not b. Let's just say g. The x is referred to as the base. The a has different names. Sometimes we call it index, the plural of which is indices. It's also called the power. Now, some teachers also call that the exponent. But then that leaves me with the question, what do we then call this? Right? I actually call that the exponent. But some people actually switch these, so they call this the power and this the exponent. I don't think it actually matters because I don't think they're going to ask about that anyway you take it, right? So, if we have x to the power a, multiply by x to the power b. So the shortcut here is that we're simply going to add powers together. All right, so for example, if we have 2 to the power 3 and then multiply that by 2 to the power 5, all we have to do is add the powers, 3 and 5, and we get 2. Correct, when they multiply, add. You add in the powers once you have the same base, right? If it was 2 to the 3 by 5 to the 2, we couldn't proceed any further, right? The reason is 2 to the power 3, the 3 of the power tells us how many instances of the base we're going to multiply together. So the base is 2. 3 is the number of 2s we multiply together. So that's 2 by 2 by 2. Question?
No, I'm checking if this is an error because now so this question. They told you that they gave you the bearing of R from H, but now here they're asking for the bearing of R from H. They gave it to you in the beginning.
Calculate how far due south. That's distance, that's not bearing.
That makes sense, yeah.
Right, and then 2 to the power 5, right? So the 5 tells us how many 2s we multiply together. But now, if you have 3 of them here and 5 of them here, how many 2s you have in all? You have 8, right? So you could also, this is 2 to the power 8. Right, so that's why the shortcut works, okay? Second law of indices, if we have x to the power a and we're dividing by x to the power b, right? So if when you multiply, you have to add the indices. And if division is the opposite of multiplication, guess what we're going to do with the indices when you divide? Opposite, you're going to subtract them, right? Uh-huh. Or how far do you south, right? So you have to kind of draw a line going down. So it's like you're creating a right angle triangle here. And you're looking for the vertical.
Okay.
So you have the hypotenuse, I guess, and you probably have an angle or something.
Yeah.
No problems. Right, so let's say you had 3 to the power 7 and divided 3 to the power, let's say 5. So what we do is we subtract and we get 3 to the power 2. Right? Now another way you can show division is like a fraction, one thing over the other, right? So you could have 3 to the power, so pick a big number there, boys. So 3 by 3, by 3 by 3, by 3 by, sorry. Hello. It's a bit loud. Right? All over 3 by 3 by 3 by 3. So just like how you could cancel between numerator and denominator, you could do that here too. 1, 2, 3, 4, 5 and we'll cancel. And you're left with how many? 2 of them. And 3 by 3 can also be written as 3 to the power 2. All right, so far so good? Okay, there we go again. So what about where we have x to the power a, but you're raising that exponent to the power b? So what we do here is we simply multiply the indices together. All right, so let's say we had 2 to the power, actually, hold on. Let's say 4 to the power 3, then squared. Right? So you can say that's 4 to the power 3 multiplied by 4 to the power 3. And if you pull back from rule 1, what do we do with the powers when you have the same base and you're multiplying? You simply add them together. So 3 plus 3 will give us 6, which is the same as taking 4 to the power of 3 by 2. And what do we get? 3 by 2 is the same 6. Right. Justin Khan. Hey, Justin, thanks very much. Nice. What that means. For me? Oh, thanks very much. My Justin. And he's on. Right. Okay. Right, so we have that. Okay. Now, this is going to be a little interesting, a little different. If we have a negative power, that kind of turns it on its head, right? Because if the power tells us how many instances of the base we multiply, how do we multiply a negative number of times? But that's where the understanding of the negative sign comes into play. A minus sign means opposite, right? For example, addition is where you take, let's say you had 2 piles of rocks and you push them together, right? And we could do the opposite. We could pull 2 piles we could pull 1 pile of rocks apart into 2 pieces, not so? How did we get 4 to the third power? I made it up. I just made up the example. Yeah. So the opposite of addition is subtraction. You could even think of it as, let's say you had a stick and you put the next stick on top of it. How many sticks you have now? You have 2. And if you do the opposite, you just take back out your stick. You have how many sticks now? 1. So the negative sign simply means do the opposite of what you're accustomed to. All right? So if when you raise to a power, generally speaking, you repeatedly multiply, right? If you put a minus sign, you're doing the opposite. What's the opposite of multiplication? What's the opposite of multiplication? Division, right? So what we're doing here is we're actually dividing repeatedly by x to the power a, right? So for example, if you have 2 to the power minus 3, this simply becomes 1 divided by 2 to the power 3, which is the same as 1 over 2 by 2 by 2, which is actually the same as 1 divided by 2 and divided by 2 and divided by 2. All right? But this just looks kind of messy, right? Repeated division like that. It's a little easier to kind of express it like that. Cool. Now, number 5. Yep. Parents?
Yeah.
All right. I'll see in a few minutes. We'll take them home, right? All right. Now, we have a couple of kind of easyish ones to open up. Any base raised to the power 1. So again, remember, the power to which a base is raised tells us how many instances of that base we multiply. You can put it on silent. Thanks. So if you have the number 1, that means you just have one item, right? So any base raised to the power 1 is just that same base. Yeah, I have to go upstairs for it, but remind me to do it.
Okay, cool.
I have it Friday too. Did I pay you Friday? Right. Okay. Cool. Yeah. Now the other one I have here, which is a kind of easy one, but a little strange for some people, is to the power 0. Right. So how do we conceive of the power 0? Let me just let in Donovan, you know how you're doing. Good to have you on. Yeah, I started a bit late myself, about 6:45, so you didn't miss too much, to be honest. Actually, 6:55. So we just recapping some laws of indices here, and we're going to go through some of the possible questions on that topic specifically, right? Yeah, so we just recapping some of the laws. Okay. So we actually get to the power 1 here, right? Now, how do we explain this, right? So again, it depends on the definition of what an index is, right? Now, let's keep it simple. Let's say you had x to the power 3 divided by x to the power 3. Now, based on rule number 2, what do we do with the powers when you're dividing? You simply subtract them, right? So if we come up here now and we do x to the power 3 minus 3, 3 minus 3 will give us 0. But that doesn't tell us why it's 1. But what was the other way of expressing division? Putting one item on top of the other. And even if you consider this statement here, we're dividing something by itself, right? So on a side, if you take any number and divide it by itself, what do you get? 1, right? So any term divided by itself will give us back 1. So that's why x to the power 0, any base to the power 0 is equal to 1. Make sense?
Yeah.
Right. Which rule? Oh, so like if you had like 2 to the power 4 divided by 3 to the power 2, right? You'd have to plug it in a calculator and work it out. And algebraically, you wouldn't be able to move forward. You can't simplify. All right. Hey, Paige, even though you're doing. Sorry, say that again? We should. But it shouldn't be a busy season, and it has no big set of weather, so why are you delayed? Alright, so let's sit tight. Can't do anything else unless you plan to swim back, which I don't advise. Well, my brother went in the boat recently, and he said never again. Oh boy. If I could help it, not me and no boat, no? Alright. Yeah, so if you don't have the same base, you can't apply the laws. Right? Yeah, Paige, we just recapping some of the laws in this before we tackle the questions, right? Alright. So this one tends to be the strangest one for most people, right? If you have x to the power 1 over a. So 1 over a is a fraction, like a half or a third, right? But the numerator is 1. So what does that mean? Well, we said that index is the number of instances of the base that we multiply together. So how do we multiply a fraction number of times? What does that mean? So this actually has a strange meaning, right? This is asking us for the root of the item. All right? So let me explain. Let's say I had 8 to the power 1/3. Now 1/3 is a fraction. It's one piece out of 3. So what they're asking for is, can we split this into 3 equal pieces? Right? So you're not dividing 8 by 3, because what we have to do is multiply those 3 terms to get back the 8. And they have to be the same terms, right? So you're breaking up 8 into 3 pieces, which are all the same, and you're multiplying them, right? So obviously we know 8 can't divide by 2 is not that. What about 4? 4 by 4 is 16. So that'll work. 3. 3 by 3 is 9. So that's bigger than 3. What about 2? 2 by 2 is 4. And then 4 by 2 is 8. So 8 to the power 1/3 is simply 2. All right. Let's try the next one. What about if we had 81 to the power of a half? Right? So a half is 1 out of 2. So how many things we have to break up 81 into? We have to break it up into 2 pieces. The same two numbers, the same number twice, and when you multiply it together, you get 81. So basically asking for the square root of 81. So what number by itself is 81? 9. Very good. Correct. Now, the addendum to this is, what about if we raise the base to, well, this is called a rational index, by the way, right? What about if we raise that base to a rational index where the numerator is not 1? What about if, for example, it was b over a, where b is not equal to 1 or 0? All right. Let's try one, right? So let's say we had 8 to the 2/3, right? So directly above it, we had 8 to the 1/3, and the answer was 2, because what we were asking for there was the cube root of 8, right? Now we know that if we break up 8 into thirds, equal numbers, that when they multiply them together give us back 8. We know we got 2, right? It was 2 by 2 by 2. Now in the item on top, the numerator is asking us for one of those items, which is just what? 2. Down here was the numerator. 2. So how many of these we taking? 2. And what's 2 by 2? Right? Now, another way you can think of this is as follows, right? What you could do is you could either break up 8 to the power 2/3 as 8 to the 1/3, then squared, or 8 squared, then raised to the power 1/3. Right? Now we know from above here, 8 to the power 1/3 is 2. So this becomes 2 squared. And 2 squared is 2 by 2, which is 4. Or 8 squared is 64. And then we're looking for the cube root of 64. Now for that, you could probably use a calculator. You understand both of them? Yeah, because the idea is scale down. So like in this piece here, what I do is I scale down first to get the smaller number, and then I will raise it to this power. Right? If you think about it, if you look at the fraction, the numerator is the number on top. So you could usually associate on top it going up, and the denominator is the number below, so that's going down. So what I like to do is I'll take the number below and scale it down, because you're almost always guaranteed to get a smaller number when you use the fraction first. And then I'll raise it to the power. So when you do that, you're going to get a bigger number. All right? But you could do the reverse too. You could raise to the bigger number first. You could raise it to the numerator first, get a bigger number, and then scale it down. Right? And like I said, if you have a calculator to use it, you can just plug it in. Right? And to be honest, if you just plug it in a calculator, you're good to go most of the time. All right? All right. So, what about if the numerator is bigger than the denominator? Right? Let's say we had 27 to the power 4/3. Right? So again, the 3 is the denominator. That tells us how many pieces we have to break up 27 into to multiply. Right? See the examples. I'm going to finish this now, mini. Because I kind of in progress with this one. Right. So 27. What about 3? 3 by 3 is 9, and 9 by 3 is 27. All right. So now what we've done is we actually took the 27, applied the power of 1/3 first, and then that gave us 3. So now we're to the power 4. 3 to the power 4, if you plug it in your calculator, you get 81. Because you could also consider this as 3 squared squared. 3 squared is 9. 9 squared is 81. Well, like I said, if you have your calculator and you know how to use it, you could always just, plug in those things. All right, so what I'll do is I'll give you a minute or so to finish right now. But then we're going to go back to the questions right here. And I'll do 1 or 2 as an example. And then leave you all to try the rest. So D'Angelo, Donovan, and Javi, if you guys are good with the examples and the rules, give me a quick Genie chat. If you need me to re-explain, give me an R. R. Which particular one to make? We kind of had a press forward. Let me do some examples from the actual papers and maybe that might help, right? Okay, cool. All right, so everybody has a copy of the paper, right? All right, Google Meet, we're gonna do, let me send a picture of this in the chat for you guys, right? Right, so as you can see, between 2015 Jan and 2025 Jan, and all the May papers in between, I only found 5 indices questions. It's kind of poor. There's like 20 papers. So like out of 20, it came 5 times, which is like what? 1/4. So anyhow, all right. So I'll do a couple as examples, right? Okay, so like here. You have p cubed by q squared multiplied by p by q to the power 5, right? Now, what's the understood operation between these two terms here? Multiply, right? And between these two, multiply as well. And what do we know about multiplication? The sequence in which things are multiplied doesn't matter. It's commutative, right? So what you could do is you could switch around this stuff and put all the like terms together. So you can put all the p's together. So you can put p cubed by p. Now, where no power is explicit, what power is understood? 1, right? All right, so here now, we have the same base and they're multiplying. So what do we do with the powers? We have to add them. We have p to the power 3 plus 1. And same thing here, q squared by q to the power 5. It was q to the power 2 plus 5. 3 plus 1 will give us 4. 2 and 5 will give us 7. Okay. Now, across here with 2016 Jan, what you could do is you could rewrite it a little bit. Now, this is a fraction, right? It's a rational expression. You have a numerator and a denominator. What is the understood operation between numerator and denominator? Division. So you can rewrite this as the numerator then divided by the denominator. So you can work out inside the bracket first and then do the division after. And of course, there's no power here by the x. But what power is understood? 1. Yo. Look, put it back on you. All right, just now. I'm coming. All right, okay. So guys, I'll giving you all for a little bit. Sorry, I'll giving you all some time to try the questions. All right. So as you mean, because some of those numbers were kind of small. If anything, still too small. Let me know. Here's Julia. Right. Hey, Julie, even how you doing? Good to see you on today. All right, we're doing some algebra revision for maths. And what I did is I went through the papers between 2015 and 2025 Jan, and all the May papers in between. Oh, okay, no, excuse. I think you dropped this pen by your left foot. Thank you. Yeah, Julie. So I pulled out all the like a section of my topic. So we're working some indices questions now. After that, I think we're going to do some some basic solutions of linear equations, maybe some transposition, and maybe some simultaneous. So we're gonna be like basing some algebra for the next couple of weeks or so. Right? Some stuff might be easy, some stuff might be not so easy, right? So we're realizing, right? Just give me a sec to make a little and come back. When I come back, we correct.
Oh, serious? Oh. Oh, okay. So it looks like the first one you would have done. That's the second one. Yeah, okay. Anyways, yeah. You did this first part. You're on this part now. Woo! Yeah. How did you find it? That's a photograph. Sorry. Sorry. I'm looking now. I have cats. I have cats.
All right, folks. Sorry. All right, so I did that first one there. Okay. So 3 by 4 will give us 12. X squared by x to the cube, x cube will give us x to the power 2 plus 3, which of course is 5. And it's 2 to the x. Sorry, 2 by x to the 1, right? Right, so you could also write this as 12 by x to the 5 over 2 by x. And you could actually split that. All right, 12 divided by 2 will give us 6. And if you have x to the 5 divided by x to the 1, when you're dividing and you have the same base, what do we do with the powers? You subtract them, right? No, man, that's not what I wanted. Right, we'll go back and do 2023 just now, right? 2019 first. So here, you can pull apart and do 3 by 4 by p squared by p to the power 5. Of course, 3 by 4 is 12. When you multiply and you have the same base, what do we do with the indices? You add them. 2 plus 5 is 7. All right, this one is a little more involved. We need to, sorry. Now, this is a fraction, as is this. This operation is division. And when we are dividing with fractions, what's the protocol? Change divide to multiply, and you invert the divisor. So you'll get 20 y squared over 21 x squared. And you can do this in different ways, right? You can multiply the numerators together first and then cancel, or you can cancel and multiply. I'm not sure what the call is on that, but I would say just to be safe, put alternating. Just put alternating angles. Yeah, you can put Z or alternating angles. You can literally write that Z or alternating angles. Right, so check it. So you could cancel, like 3 into 3 goes 1 time, 3 into 20 goes 7 times. 4 into 4 goes 1, 4 into 20 goes 5 times. Right, now when you multiply out here, x by 5 by y squared will give us 5x y squared. And then y cubed by 7 by x squared will give us 7 x squared y. Right, so now, right, the 5 and the 7 can cancel. So this is a 1 here, that's a 1 here. No, y cubed. Sorry. Yeah, so basically what happens is well, so what I was showing Q now was if you're not sure how to apply it here, like that, you could write it out like this. All right, x is x by x and y cubed is y by y by y, right? So, sorry. So 1x will cancel, as will 2 y's. All right, so what will we end up getting? 5 over 7y. 7xy, sorry. Okay. I'll hold on pause for a minute there. Donovan and D'Angelo, and Javier, just give me a quick G, and Juliana, if you're good with that, please and thanks. If you need me to re-explain, give me an R, let me know. Right, you have different ways you could do that question, right? But like I say, it's really up to you how you approach it. That's just one suggestion. If you want to send me a picture of your work, you know, you could organize that via WhatsApp. All right, Lumic, good job. All right. Fiona, are you okay with that? All right. Julian, Cliff, you okay with that? I give me the slope. You all right? If you're not, let me know, right? Okay, cool. How are you doing there? Good? All right. All right, let's get them a minute again to copy down the stuff, right? Check any messages. Oh. What's that? Oh. Often we'll be like Monday and Wednesday, 4 to 6 is PUA, and then half 6 to half 8 is math. I was running late these days, but I'm trying to be on time. All. Okay, cool. Utilize it now. All right, cool. All right, cool. That's all I want. That's what we here. All right, Khalif. So we okay with that one, right? All right. We have a couple of easy ones here now. I think most people got this one, right? So if we have x cubed then raised to the power 2, we just multiply, right? And we get x to the power 6. Okay, now you're dividing. So you'll subtract. It'll be y to the power 8 minus 5. And when you minus a minus, it becomes a plus. And 8 plus 5 is equal to 18. Right? And as you can see, that one was pretty recent, then Jan 2023. And then Jan 2024 came a little different. All right. So it says find the value of r by x squared by x to the 6 is x to the r. So if you consider x squared by x to the 6, when you have the same base, what do we, and you multiply, what do we do with the indices? You add them. You have x to the power 8. And we are told that this is equal to x to the r, which means that what's r? R is equal to 8. They should put like the answer so they can see it easily, right? They get more marks for the working. But like each of these was like 1 mark now, so. No. Right. Now here, they're saying s cubed is equal to 8. And the interesting part is we did this already in the examples, but you mightn't remember, right? So, well, check, let's see. S cubed, right? What is S cubed? S by S by S. 3 S's being multiplied together. So S by S by S is equal to 8. Right? So you could guess, right? 8 is an even number. You had to start with 2. 2 by 2 is 4. And 4 by 2 is 8. Now, the other way to do it is to say, okay, look, if I'm looking to find S, I want to kind of undo the cube. To undo a cube, I have to find the cube root, right? So S would be equal to the cube root of it. And again, if you have a calculator and you know how to use it, look at it and you have the answer, right? Okay. 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 You know, if you're done with that last one then. All right. Yeah, talk to me. You okay now? All right. Khalifa and Julie. Yep. Okay. All right. Google Meet. You guys know the drill. So you guys good with that? Give me a quick G in the chart. All right. Good night. Where people they buy? I have a question, but quick see. All right. Okay. All four. Thank you very much. Okay. That's laws of indices. All right. Huh? No, I'll print it off here. Right, so one. Wait, is that the right one? Okay, yeah. So hold on. 1, 2, 3, 4. Okay, just a moment. How about 8? All right, 1 second. Yeah, well, they give the 8 to us here. Right? Right. Or are you talking about the orange? Doing. Right, so, yeah. How I got the 8 was I multiply 2 by 2 by 2. Yeah, 1 second. I just want to print the rest of these things for everybody. Yeah, guys, normally all this stuff is already put in PDFs and printed out, but just these days not running as per usual. So I just doing what I can or what I have where I am. So I do beg your indulgence and thank you for your patience. All right, so these questions are basically plug and play. So what that means is these are the substitution questions. So all you're doing is you're plugging the values into the equation they give you or the expression and working it out. Well, so all right, to get the marks, what I would suggest is show that you make this simple. So for example, it says 2 by pi, and they say use pi as 3.14, right? So you can say 2 multiplied by pi, or if you prefer, you could do 2 multiplied by, right? They both mean the same thing, all right? And then you have the square root of L over G. So L is 0.625 divided by G, which is 10. So you should show the substitution. You can plug it in the calculator, and you're good to go. Yep. Well, once you know how to do it properly. No problem. Well, if you know, we're gonna know. Right. So again, you could just plug it in your calculator. That's actually probably most efficient thing to do. Right. 0.625 divided by one quarter. So anybody get 1.57? Now, for my purposes, I will have to do 1.57. Give him a read. All right. That's the first one. All right, good. Ready for your next one? All right, cool. All right, Google Meet, just give me a quick G. All right. Can you re-explain me a R? No. Oh, wait. Let me put that Juliana is present today. All right, thank you very much. All right, 0.496 times. All right, time. It's probably you plug it in the calculator incorrectly. So the brackets are your friend. All right. So what I would suggest is do the 0.625 divided by 10 first. Then find the square root of that. Then multiply that by 2 by pi. You get 1.5. That's interesting. I wonder why. So then maybe a calculator set around enough mode for one decimal place or 2SF. That's a strange one. See if you can hit the reset button and try it again now. Okay, next question. So May 2015. Right, so this is kind of an easy one. A is 4, B is 2, C is minus 1. So they want A minus B plus C. And then this one down here is 2 to the A, sorry, 2 multiplied by A to the B. Right, the power B is only applied to the A. It's not applied to the 2, huh? A minus B plus C. Right, in case you weren't sure what to do. Right, I know you had to work it out. Now you can plug that shit into your calculator, by the way. Right? So what would happen in this one is you would raise a to the power b first. Yeah? Hey, Ivy, what's up?
Yeah, I know.
Yeah, so when I saw simplified, I can transfer numbers first.
Right, so Chelsea's saying 32. You're pretty saying 10. All right, well, let's take a look. All right, so 4 minus 2 is 2. And then 2 plus minus, okay, so we could do that. So 4 minus 2 is just 2. When you plus minus 1, you just get minus 1. And 2 minus 1 is equal to 1. Now 2 by a to the power b is equal to 2 multiplied by 4 to the power 2. 4 to the power 2 is 16. So we have 2 multiplied by 16, which is 32. Yeah, so if you had put it in your calculator, let me know now. I'll see if I can advise you some way, somehow. Because trust me, sometimes even when I was in Form 4, Form 5, plugging stuff into the calculator wasn't my strength. So it takes some time to learn. All right, so my Google Me people, DeAndre, Donovan, Juliana, and Javier. If you guys good with this page, just give me a quick G. All right, thank you. All right, in class, if we okay what's on the screen currently? We'll go again. All right. Sorry, I was to tell you, don't worry with this. Don't worry with part 2 for now. Actually, I have that in the next section with more of those. So what I want to do, maybe we can do that next, right? So because after this one in this batch, we have like 2 more, right? But I have all of these ones here that have the transposition in that section. So we'll do that one next, right?
Our original formula.
Up and there. Where the screen went? So? Yeah, it's not gonna show up, there the screen blank out. Restart. No, okay, you back up. Follow. Hey Chelsea, you're going on. Good man. Oh yeah, thanks for the heart. I appreciate it.
Always. So I don't know.
22.2. Let me take a look. Not sure where. Let's take a look, right? So determine the value of d when h is 29. So it's square root of 4 by 29 all over 5. Okay, maybe it might be. So 4 by 30 is 120. 4 by 29 would be 4 less, which is 116. So we have, we have 116 over 5 as what? 23.2? 4.8. Right. You mean square root, Chelsea? Yeah, I think you forgot to square root it. Okay, let's see. Calculate the food. So just to be sure, 4 by 29 is once. Just give me 1 second. I'll just do this some other time. Yo. Huh? Oh, drag. Right, and then divided by 5, right, and then square root, you get 4.816 back. So when they wanted to what? 3 significant figures, right? So you're stopping at the 1, but the digit to the right of the 1 is 5 or higher. So you have to round the 1 up by 1, which will make it a 2. So 4.82. Correct the 3 significant figures. Square it now, right. Right. Google Meet, Donovan D'Angelo, Trian and Javier. So now put G in the chat, go over that, present us. Right. Ladies, you got that? Right, Q&A, we cool with that? So you talk to me. You there? Right, cool. So it's I'm frozen. The frozen, Chelsea. If I'm still frozen, you had to jump out and jump back in. It seems to be working on my side. Right, okay. All right, so the print on this is a little bolded, right? Okay. So the quantities F, M, U, V, and T are related to the, right? So F equal to M by V minus U all over T. If anybody recognize from physics, this is actually acceleration. V minus U divided by T is A, acceleration. And force is equal to mass by acceleration. Anyhow, all you have to do is plug in M, V, U, and T and this simplify, right? So organize that. We'll correct and revert. Where I come from now? Who gave? Oh, thanks very much, Gabe. I appreciate it. I like 12 cents in total for like a year and a half a stream, but that's all right. I'd enjoy it to do that. Anyhow, right. Shall we? No. 9. Anyone corroborate that? All right, so F. So M is 3 multiplied by V minus U all divided by T, which itself is 1. So when you minus a minus, you get a what? You get a plus. Right. So what's going to happen? You're going to get 3 multiplied. So 2 plus 1 is 3. 3 by 3 is 9. Okay, 9? Yeah. And the value of F is 9. Very good, Riri. All right, cool. D'Angelo, Donovan, Julian, Javier. Come up with G. Yeah, we good there. Khalifa, Julie, we go with that one. 9. I saw somebody say 10. I don't know why. Did I hear correctly? Oh, okay. All right. This one was May 2021. Two quantities N and T are related as follows. Find the value of n when t is equal to 49. So what they're asking for here is the square root of 49, which is what? That's what? And we done. That's it. They get a mark for that. So they give it that one. 7, correct. Okay, cool. So now we're going to switch up gears again and we're going to do the transposition, as in changing the subject of the formula, right? All right, so let me just print out this stuff for you all and we go from there, right? No. Supposed to give me 3. Stupid.
You're ready for our next one. Oh, that was last paper.
All right, just give me a minute again to finish building the next 4 and then we'll start from top, right? Should be able to get through all of these. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 minutes piece, if so long. Okay, sorry, just give me a minute. Like I said, normally everything is printed out and prepped already before class, so I don't spend time in class doing this. But these days it's not running according to my schedule. A little frustrating, but sometimes I don't know when to go with the flow, and sometimes I don't know when to obstruct the flow and find a way to do what you gotta do. And funny part is you might never know if you made the right choice. Other times you will know instantly. Okay. Right. All right, so you could start with that one in the meantime. I'm gonna give all the stuff that's printed in here. All right. I'm gonna see that one little TikTok family, guys, which is see Julia Star, Boy Kev, that stuff there, Lily, Azel, Ezel, yeah, pronounce that properly. Syria. Hazel, or Azel. Hazel. Yeah. Azel. No, no, no. I like to pronounce people's name correctly because mine is often butchered. Purple thing. Lady purple thing. Okay. Hey guys, sorry. The radius r in terms of the all right, let me see. Let me see. Oh, thanks, Hannah. Thanks, Ali. Okay, cool. Right. So when we're transposing or changing the subject of a formula, we're trying to remove everything currently attached to that item or undo it, right? And to undo, no problem. No, it's no problem. No problem. It's no problem at all. Right. So we have V is equal to pi r squared by h. Right? You can even rewrite it as pi r squared by h is equal to V. We're trying to make r the sub to the formula. Currently, r is being squared, and then you're multiplying, well, pi by it, and then it by h. So pi and h are both connected by multiplication. To remove anything connected by multiplication, we need to use the opposite operation, which is division. So you could divide by pi by h one time. Now, what I'll do is I'll show you the long way. So if we take the same pi r squared h, and again, we're trying to get r by itself, so you want to remove everything currently attached to it, right? So pi by h, so you divide. And we're dividing because pi and h are connected by multiplication. And to remove something, use the opposite operation. The opposite of multiplication is division. But of course, whatever happens on one side of an equation must happen on the other side as well. So on the left side, pi will cancel with pi, h with h. So you're left now with r squared equal to v over pi by h. And now we're left with r squared. How do we undo a square? We have to find the square root. So we're going to find the square root of r squared. And of course, whatever happens on one side of an equation must also happen on the next side. The square root of r squared will just give us back r. So long story short, r is equal to the square root of v over pi by h. Right? Now, you don't have to show every single step I have here. I did it with extra detail for illustrative purposes, so you can see why things are canceling, why I'm dividing, or why I'm multiplying, or whatever the case is, right? That's what you got. Okay, cool. Good job, Ray. All right, all right. Google Meet, D'Angelo, Donovan, Julian, Javier. Just give me a quick G, if you're good with that. All right, lovely. All right. The next question I'm going to do is the Jan 2019. I'll pull it up just now. Multiplying letters. Okay, I want to pronounce your name properly. Is it Azel or Azel? Or something totally different. If it's Azel, give me one. If it's Azel, two. Hit the chart. Azel. Okay, cool. Thank you very much. All right. I'll see you like that. All right. Web page. It wasn't on. What? Okay. Okay, so look up now. Okay. I'll give you a minute or so again and then we'll switch it up. Correct. Um, Okay, let's go. Jan 2019. Right, make X the subject of the formula. Right, so what I'll do is I'll give a minute head start for those who want to try it on their own. Right, and then we'll talk through it. Right, so remember you're looking to solve for X. So you want to remove everything currently attached to it. Right? My philosophy is start from the furthest point. Start from the item furthest from the X on the same side of the equal sign. So you'll start by removing this and then this. Right? But you don't have to. That's just a general protocol, right? And what we call the reverse order of operations. Right? The order of operations is the BOMDAS or BODMAS or PEMDAS or whatever you call it, right? So any addition or subtraction will happen first, then that, and then the brackets or forwards. All right. So you move the 3p. You move the 3p, right? So you have to subtract that. Because you didn't move the y, right? Right. So because you moved the 3p, you subtracted it because it was added on that side, right? So it should be y minus 3p. Right? And then you were dividing by the 5 initially. So to remove something by division, you have to multiply. Right? 5y minus 50. All right. This is GCSE curriculum. What is it? What is it? I'm hoping it's curriculum. This is the CXC O level, which is it's called CSEC, but it is based heavily on the GCSE curriculum. Yes. Right. We are actually descended from, we were colonized by the British, and we had their exam system, and we just basically renamed it and changed a couple of things. But the majority of stuff on this syllabus is applicable to the GCSE. All right. So again, you could approach this a couple different ways. So again, what I like to do is start on, if I'm looking for X, I want to remove everything currently attached to it. What I say is remove things that are furthest from it and then work your way inwards, right? And on the same side of the equal sign. So what's the furthest item from the X? The 5 or the 3p? Which one is literally further? The 3p. How is the 3p attached? Addition. How do I remove something attached by addition? I use the opposite operation, which is subtraction. So what this could look like is this. I'm subtracting 3p. I'm taking it. And of course, whatever happens on one side of an equation must happen on the next side. So 3p minus 3p will cancel to 0, leaving us with this now. Right? What most teachers will tell you is carry this across and change the sign. But the problem with that is that it creates a problem later on. Right? Mora. Ask, hey, look, Mora, in the dance way. How are you doing? Evening. Right. And the last thing attached to the X is the 5. What operation is division? We're dividing by 5. So to remove the 5, you have to use the opposite, which is multiply. That's correct. So what it would look like is this. It multiply by 5. And of course, whatever happens on one side of an equation happens on the next side. So the 5 will cancel. And of course, you could apply. Now you could leave it as 5 multiplied by y minus 3p equal to x. Right? Alternatively, if you prefer, you could use distributive law and expand and simplify. It multiply the 5 by everything on the inside. So you get 5y minus 15p. This is perfectly fine as well. Right? Okay. Yeah. Okay. Google Meet. Are we good with that? Are we going again? Go again. John 2020. Cool. Make K the subject of the formula. Who's that? Well, that's side. Good luck and I see you tomorrow. Hope it goes well. Hope you're prepared, or they can possibly prepare. And that the exam comes good. Check it tomorrow and I know how it goes, right? So guys, that's my cousin. A big thing tomorrow on the dance. Right, there we go. So okay, I'll give you a minute again. Right, here we go. Square. Oh, all right. I like it. Good. All right. What happening? They went and borrow Vine from Tarzan for graduation day. That went on. I understand. Huh? I don't know. I thought you were slipping down. So that buy, borrow, grow went on. You rent it or? Yeah. I didn't ask it. I don't know. Really? Okay. So you plan to sell it or just? Oh, okay. No, you can sell it and make plenty money. You know. Me? No, I cut mine. I good. Yeah, I rather. This thing here, you sneeze and it hits somebody high out. I don't know, you know. Or you get whiplash or something. I don't know. Or like you're going on the road and somebody calling it and they head too fast and you know. Yeah. All they want to see the hair. Long way back. All right, so okay, there we go. All right, cool. So we want to solve for K. Now we have multiple things happening to K, right? So the first thing happening to K is that we're squaring it, right? So the first thing is that you're squaring it. The second thing is that you're multiplying it by pi. The third thing is you're adding 3t. So if you want to solve for K, you have to go in the reverse order and undo, right? So if you're going in the reverse order, the first thing we're going to undo is the addition of 3t. How do we undo the addition of 3t? We minus 3t. The second thing, we have to undo the multiplication by pi. How do we undo multiplication by pi? We divide by pi. Now, how do we, the last thing is the first thing, how do we undo squaring? You find the square root. So you can also try to analyze like that. Go from the inside out, but then you had to reverse and invert. So, right. So the first things first, we're subtracting 3t. So if you subtract 3t from the right-hand side, it'll cancel that. But don't forget, whatever happens on one side of an equation must happen on the next side. So you have to subtract 3t from both sides. The next thing you have to divide by pi. When we divide by pi here, it'll cancel. The last thing we have to do is undo the square. To undo a square, to find the square root. So minus 3t plus 2a. That's fine. That's the same thing you do. Nah. I mean, only way that would make sense is if you brought the 2a across here. But then you had to carry this across here. And you get minus pi by k. But then you can divide by minus pi. So, I mean, you could do it that way, right? You could even get rid of the pi first if you want, huh? It's just going to be a little more complicated. Let me show you. Just for the sake of argument, let me show you, right? So check it. Again, the protocol is, like I said, the easiest way to explain. Start with the item furthest from the thing into kind of transpose 4 and work your way inwards. The truth is you don't actually have to. In some cases, you could actually start right by the item. Now, I wouldn't suggest starting with the square root first. Let's say you wanted to move pi first. How is the pi connected to the k squared? What operation? Multiplication. How do we remove something attached by multiplication? Division. So we have to divide through the whole equation by pi, right? So it means dividing by pi here, by pi here, and by pi here. So we'll end up with 2a over pi equal to k squared plus 3t over pi. And then you can move this. How is it attached on that side? What operation connects it to the k? Addition. What's the opposite of addition? Subtraction. So to move it over, you do subtraction, right? So you end up with 2a over pi minus 3t over pi equal to k squared. Now, here, you're subtracting fractions and you actually have the same denominator. So you could simplify that by simply putting them over the common denominator. And the last thing to do is to find the square root. So you don't actually have to do it that Sakura died. Oh, let me see. Which Sakura? Sakura Haruno from Naruto? Or next Sakura? Anyway, right. So you have different ways you could go about doing, right? Some of them are a little easier, a little more efficient. Some are not so easy, a little more scenic. Right? It's up to you. Okay. DeAndre, Donovan, Julie, and Javier. Just give me a quick G if you're good with that, right? Even if it's just the green, you're good with it. If you don't like the blue, that's fine by me. All right. Zian, we okay with that? Kiona, we okay with that? Ladies, we okay with that? Bro? Cool. All right, there we go. Okay. Quick sharp, make V the subject. So currently V is being multiplied by T, then we add in 5, and then we square root it. So go backwards. Start by getting rid of the square root first. G, but the green. Okay, cool. Green is good. Like I say, you don't have to understand the blue, it's not a problem. Once you understand one, at least one of them is fine, man. Just bite myself. Ow. Real near, boy. Where's V? Who's that? I was Logan had that.
Oh, the
Yeah.
that was
Right. So let's go. Right. So the first thing we want to do is to undo the square. Sorry, undo the square root. To undo the square root, what's the opposite of that? Square on both sides, right? Oh, yeah. Right, just now, yeah. All right, to undo that, you square on both sides. So, right, so square both sides. So when you square p, you're just going to get p squared. When you square the right-hand side, you're just going to cancel the square root. All right, next thing, get rid of the 5. The 5 is being added, so we're going to subtract 5 from both sides. So then we're going to get p squared minus 5. And then you're going to get rid of the t. How is the t attached to the v? Multiplication. How do we get rid of something attached to multiplication? We use the opposite. What's the opposite of multiplication? Division. All right. Okay. Yes. No. Maybe. You don't talk to me. Good there. Good now. Okay. All right. Hold on. So line 1, line 2, line 3. All right. So line 1 is just the question again, right? So to undo the square root, you have to square both sides. You okay with that? All right. So when you square p, you get p squared. When you square the square root, you just cancel the root and you get back over what's under the square root side. So far, so good? Right. Now here, you want to make v the subject. So you want to remove everything currently attached to it, right? Let's start with the 5. How was the 5 attached? Addition. To remove something attached by addition, we use subtraction. So when you subtract 5 from both sides, you get p squared minus 5. And of course, when you subtract 5 from here, it'll cancel that, leaving us with v by t. Right? And then to find v for itself, you gotta remove the t. The t is attached by multiplication. And to remove something attached by multiplication, use the opposite, which is division. So we divide this by t. And when you divide by t here, it'll cancel, leaving us with just the v. Yeah? Uh-huh. Right. Okay. Right. 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 So the trick is if anything is in a bracket, or in this case specifically, you have that square root sign, you had to get rid of that first because that's basically trapping everything underneath it. So this I can put that box on top of it, and I move the box off first. All right. Mini, what happened? What are we trying? All right. All right. This is from Jan 2025. So what we'll do this one. We'll save some for next week. All right. On the way. All right, cool. Well, I'm around upstairs. It's for 3 days after, right? Friday, Tuesday, and today, right? I get this. You never understand. Well, take one thing at a time. It is a bit tricky. I guess that's one of the right?
Yeah.
No. Then you'll have because you have this negative in front of your well, so technically when you move this k across, we have to multiply that by -1 because it's a1 positive and think about it, right? If you have negative m squared is equal to k minus s, you can't square root a negative number. Oh yeah, you can. So that's why like when you do algebra and stuff, if you square root something, it's plus or minus. Okay, cool.
So the last class, right?
Okay,
Yeah, the last day of school, so I'm
so
not bringing it.
tomorrow is
Yeah. The last day of school, I doubt. Right. One more. Took k over, which will turn the equation into 2. Yeah. All right. Okay. There we go. Right. So you have different ways to handle this, right? So one thing you could do is you could actually kind of rearrange. Okay, I'll see you tomorrow.
yeah.
But tomorrow we have Josiah
Tomorrow is
at maths.
I'm
There's a-
not sure because when I had actually exam for Friday, I was like, so they're like,
No, but Jennifer's aunt confirmed that she has projects to do during Easter. She even said that on Tuesday, so she's not coming. I want Ashley to come, so I had to confirm with her mom. Mom just said tell her.
okay,
So-
so
Most likely we'll try to do like Tuesday, Thursday, 4 to 6, and Josiah will come too.
yeah, I was almost thinking.
Okay, cool. All right.
Tomorrow.
Okay.
Yeah, Wednesday tomorrow.
Yeah, tomorrow.
4 to 6, right?
Yeah. Okay, yeah, no problem. Right, okay. So first things first. Oh, yeah, you can do that or do this. You're trying to make m the subject. Right now, m is squared and you're subtracting it. So what I like to do is quote unquote carry it across by adding it on both sides. Yeah. Okay, next week, right? Same day, same times. Right? Then we'll carry over the s. And then to undo the square, to undo a square, you have to find the square root, right? Very good. Okay. Right, yeah, this is one that give trouble because What come what, sorry? Yeah, hold on, let's know. So S. Right, now we are subtracting the m squared. We're not subtracting k, right? So technically k is being added to minus m squared. That's the trick there, right? That's what they like to do. So anytime you're trying to find for something, I have a minus sign in front. So one thing you could do is quote unquote, right. If you do s take away k, hold on, let me come on, right? So if you do s take away k, that'll be equal to minus m squared, right? Most people just drop the minus sign, but you can't, right? Yeah, that's what it's catch people, right? Because what happened is yes, the k and the m squared are you're seeing the minus, you're saying it's attached by a minus, right? But we're subtracting which one? Are we subtracting k or m squared? One? Okay, well next week, right? Okay. Right? So you always have to ask yourself, what am I subtracting? Oh, thank you very much. Yeah. Am I subtracting the k or the m squared? And the answer is I'm subtracting the m squared. But that's what you'd have to add. Sorry, that's what you would if you were trying to if you were moving the k, you have to remember, hey, well, so I have to subtract k. Right? Or we try to consider, all right, I'll see you, Nyla. What sign in front of that item? Is a positive in front of that one? Yeah, guys, sorry. I know what kind of I'm still remember because I'm real sleepy. So, and it's half past 8, so yeah. All right, thanks, man. So yeah, so we are to finish. Now, we're not done this particular topic yet. We have 1, 2, 3, 4 more to go. So on Monday, we'll finish up this and we'll do the other thing, right? I have algebraic fractions for you. I have inequalities for you. Binary operations, proportions, exams. Right? Of course, simultaneous equations. Yes, that's mine. And linear inequalities, linear equations, right? And as you can see, I don't have the factorization and stuff there yet. So that's coming. Monday, 6:30 to 8:30. Are you doing? Yeah, geometry for sure. Yeah. What I want to do. When you say triangle, you're talking about like sine and cosine rule or like regular tricks? Okay. You talking about, right, okay, well, Mishka's working that with them today. All right. All right, Google Meet. All right, I gotta go there. So Monday. Transformation. That might happen, but it might happen in very late April, the 30th, or the 28th and 30th. So next 2 weeks or so. Yeah, Chelsea. All right, Tanya. Not Tanya, sorry. Uh-huh. With the business boy. Sorry, I didn't comment on it earlier. My apologies. Yeah, I still have enough screens to keep track of all the different streaming. At Google Meet, at TikTok, at YouTube. Anyhow, but yeah, guys, I had to go. Sorry, I had to run there, but thanks for joining.